Sorry, I'm just trying to figure out which side the camera's on. Okay, this is number 82. And what we have here is 6 times the cubed root of 128t minus 2 times the cubed root of 2t. So this is going to be really similar to the one where we kind of recognize this as a perfect cube times some leftover. And whatever the leftover is matches this. So usually you get a clue here, like 2t is not a perfect cube. We can't break that down. It's prime. So what we usually can try to do is, this is usually a clue for us. And what we can do is we can take out a calculator and go, I wonder if, I mean, t is t, I see that, but I wonder if I divide 128 by 2, if I get a perfect cube. And I get 64, which is a perfect cube. It's 4 cubed. So if I do 4 times 4 times 4, there's my 64. Okay, so we're gonna split that and call that cubed root of 64 times 2t minus 2 times the cubed root of 2t. Okay, and then this cubed root of 64 here is the 4, but we still have the cubed root of 2t left over. So like this whole piece is similar to like this 24 cubed root 2t minus 2 cubed root 2t. It's like a really complicated form of 24x minus 2x, okay, which would give us 22x, right? So it's like the same idea where this is like, think of that as a unit and we have 24 of them. And here we have the same unit and we're taking 2 of them away. So when we do that, we'll have 22 of them left. And 22 of them is 22 cubed root of 2t's. So that's our final answer. So like just like this, we couldn't take these away from each other if they were not both x's. So we have to kind of like maneuver them a little bit to make them match. And that's how we can simplify it. I'm just going to go right to number 84 from here because I did write it down. So this, we're going to do the same thing. Here we are going to have to multiply it all by radical 3, but we have a decision to make. We can either do it in the beginning or try to clean this up first. And what approach we take really depends on the numbers we're given. So since here we have a radical 2 and here we have a radical 72, we can check and see if this leaves us with a perfect square if we split out a factor of 2. So if I do 2 times something, that other something is a 36. So in other words, 72 is 2 times 36. 36 is a perfect square. It's 6, right? And then that's just 6 radical 2 minus 3 radical 2. So it's handy to write it this way. I don't know why I put this on the right instead of the left. That was kind of weird. But it's handy to kind of clean it up before we start distributing this through, because that's going to make it harder to recognize ways where we can simplify. So if we do this subtraction, it's going to be 3 radical 2. And if we multiply that by radical 3, again, it's sort of like your radicals are almost like variables in that when you write this product, you can clean it up by putting the radicals together and calling that radical 6. Okay, so that would be our final answer for number 84.